Assalamu alaikum. This is part 2 of selecting a suitable method to integrate. Okay, starting with the general integration. Let's revise it very quickly. The different techniques which we have learned so far. X to any power, for instance x to the power of 4, if you have to integrate it, you add 1 to the power and then divide it by the new power, which is 5. Okay, so plus c. Now whatever is the original power, add 1 to it. Whatever is the new power, write it in the denominator. This is the first technique. 1 upon x, it is always going to be ln x, because whenever you see that whatever is in the numerator, the differentiation of that is in the numerator, then you can write ln x as the answer. For instance, I can give you an example. Ln 3x plus 5. Okay, sorry, 3x plus 5 in the denominator, and differentiation of 3x plus 5 is 3. So whenever you see that the derivative of the denominator is found in the numerator, the answer is going to become ln 3x plus 5. Okay, e to any power, integrating e to any power, for instance e to the power 2x minus 3. Okay, how do you integrate this? Whatever is the derivative of the power, first of all we write down the power as it is. Okay, if you have to integrate this, we will write down the power as it is, and then we're going to differentiate the power, which is 2, and we write in the denominator. So that is the answer. In this special case, e the power, when you differentiate x, the derivative of x is 1, so we divide it by 1, so that's why it's not written here. Okay, we know the derivative of cos x is the integration of sin x is negative cos x, and the integration of cos x is sin x. Okay, let's move on to other methods. Okay, if you have to integrate cos of 2x plus 1, we know that the integration of cos is sine, so we'll write sine, the bracket as it is, and then we're going to differentiate the bracket. If you differentiate 2x plus 1, you get 2, so you divide it by the derivative of the bracket. Okay, if it is e to the power 3x, whatever is the power, you write it as it is, differentiate it and write it in the numerator. Okay, here if you notice, in this case there are two products being multiplied, two functions being multiplied by each other, and you notice that the differentiation of 2x square is actually 2x. When you differentiate x square, you get 2x. So for this, the integration is going to be e to the power x square plus c only. Okay, I can give you another example. For instance, e to the power 5x minus 7, and the integration of this is 5, which is already found here. Okay, so the integration of this whole thing is going to be e to the power 5x minus 7 plus c. Okay, this is the case with e. Whenever you see that whatever is the power of e, for instance 3x square plus 5x square plus 5x minus 7, and here you've got 6x plus 5. You're noticing that the differentiation of this is being multiplied already, so you can give e to the power 3x square plus 5x minus 7 as the final answer for integration. This is the answer to integration. Okay, but if there's no connection between this and the derivative of this, then you can use integration by parts. Here you can use substitution, and the better idea is to substitute, take u as x cube plus 1 and go ahead with the process of substitution. Okay, here e, x, e and x, and we know that there's no link between the two, so we would go because when you differentiate x, you get 1, so this is x here, so there's no link between the two functions, so we will go with integration by parts. In this case also we will go with integration by parts. Now in this case we see that the derivative of the denominator is found in the numerator. The only thing is that if you differentiate x square plus 1, you get 2x. 2 is missing here, so if you put 2 here, and then you put in order to cancel the effect of the 2 which you have added, you write 2 here, and the answer is going to be half ln x square plus 1. Okay, here also you're noticing that the derivative of cos x is negative sin x. Negative is missing, so you can keep it as negative outside, and negative sin x upon cos x, and as a result it will be minus ln cos x plus c. Okay, the next, wherever you notice that the denominator has two linear functions, one is x and the other one is x minus 1, you can split it into partial fractions and then you go ahead with the integration process. Okay, here also we can split into, we can factorize the denominator, get the two linear factors and then do it with partial fractions. Now with odd power of sin x or cos x, you can go ahead with, you can use the identity, split it into cos x into cos square x. Just hold on. Split into cos x and cos square x, and in place of cos square x you can write 1 minus sin square x. Okay, and then go ahead with the trigonometric process. The integration of this, you can notice, you can see in the video where we are doing integration of trigonometry using substitution, and this is just a clue which I'm giving you. So cos, and just one more step if I can add, in this next step would be a cos x into, in place of cos square x we can write 1 minus sin square x. Okay, and then multiply the 2, we get cos x minus cos x into sin square x. This can be integrated directly, cos integration of cos x is sin x, and this you can use substitution here. And what substitution will you use here? U equals to sin x will be used as the substitution. The whole question is done in that video which I've just mentioned. With even powers of sin x or cos x, you have to go with the double angle formula, and you know sin square x is actually 1 minus cos of 2x divided by 2, and then you go ahead with the integration process. Likewise, you have to deal cos 4x in the same way. Cos, we know cos square x equals to 1 plus cos of 2x divided by 2, so you can square it and then go ahead with the integration process. Okay, let's do these questions today. And the first one, that means after learning all the different methods of integration, it's up to us, and it is on how much do we practice, that by looking at the question we should be able to find out that how do we go about with the which method should we use for integration. Okay, the first question, if you notice, if I'm going to differentiate this, I'll get 2x plus 2, and this is totally a different thing on the top. If I differentiate this, I get 2x plus 2, I have totally a different thing here. So I will go ahead with partial fractions. I will divide, factorize this and get the two linear factors of this as a first step. So I'm doing that. Okay, x square plus x 2. Okay, if I factorize x square plus 2x minus 3, I will get x square plus 3x minus x minus 3. X is common, x plus 3, minus 1 is common, x plus 3. One bracket is x minus 1, the other bracket is x plus 3. So I can write down the two brackets here. Okay, I'm not writing down integration here. I'm just going through the simplification process. I can write x minus 5 upon x minus 1 into x plus 3 as a upon, I'm going to divide it into two linear factors, a upon x minus 1 plus b upon x plus 3. Okay, I'm going to multiply a by x plus 3, and I'm going to multiply b by x minus 1. Okay, and I have x minus 5. Since once you take out the LCM, the two denominators are the same, so you can just get rid of them. Okay, I'm going to use x as, I'm going to take x as a negative 3. Why? Because I want this to become 0 now. Minus 3 plus 3 should be a 0, so that it simplifies the process. So if I take x as negative 3, it will be minus 3 minus 5 is a minus 8. I'm substituting x is negative 3 in this whole thing. So this is going to become a 0, plus b, negative 3 negative 1 is negative 4. So b equals to 2. Okay, moving on to, if I take x as a positive 1, this whole bracket will become 0. Okay, let x equals to positive 1. So 1 minus 5 is a minus 4, a 4, and this whole thing has 0. So 4a equals to negative 4, a equals to negative 1. Once I get the value of a and b, I can plug it into this. Okay, that means I can write a is negative 1 upon x minus 1 and b is 2 upon x plus 3. Now I have to start with the integration process. I am dealing both of them separately. Okay, so when I integrate this, I will get when I differentiate this, I get 1 only. I have a negative 1 here, so negative 1 I can take out as common. Negative ln x minus 3 plus 2 is also something which is extra, so I can take it out as common, and ln x plus 3. I can write this as ln x plus 3 squared minus ln x minus 3, which can be written as x plus 3 the whole square upon x minus 3. This is the result of integrating this. Okay, moving on to the second part. Now if you notice, this is also a fraction like the previous one, but the differentiation of the denominator, which is x square plus 2x minus 3, if you differentiate this, you get 2x plus 1, 2x plus 2. Okay, and whatever is the numerator, if you notice that if you take out 2s common, this will be left here. If I take out 2s common from this, x plus 1 will be left. So what I can do is I can add it to here. I can keep the denominator as it is. Since I've added 2 on my own, in order to cancel the effect of this, I can write 1 upon 2 here dot dx. So this will become half ln x square plus 2x minus 3 plus c. This is the final answer to this question. Okay. So we don't have to use partial fractions here. Whenever you see that the derivative of the denominator is found in the numerator, which should be 2x plus 2, but it was instead just x plus 1. So I added a 2 on my own. To cancel the effect of this, I divided by 2 here and outside. So that's 2 and 2 can cancel out. And it will be ln x square plus 2x minus 3 as the final answer. Moving on to the next question. Okay, we don't see a connection between the two because with ln, as I just gave an example, that whatever is the power of ln function is 2x square minus 4. The power, when you differentiate the power, you will get 4x. So if 4x is written here, then you can say yes, the derivative of this is already being multiplied here, so the answer is going to be 2x square minus 4 here. The answer of integration is going to be e to the power 2x square minus 4 plus c here. But in this case, we know that the derivative of the power of e, which is x, when you integrate x, you get 1, not x. So these do not have a connection between the two, so we're going to use product law here. Okay, so if you look at the word late, this is algebra and this is the exponential function. So algebra comes before the exponential function. That means you will take this as u and this as v dash. Okay, so u is x, so u dash is going to be 1, and v dash is e to the power x, so v is going to be whatever you take as v dash. In case of integration by parts, you have to integrate this. So integration of e to the power x is going to be e to the power x only divided by 1, so that doesn't have an effect, so you don't need to write divide by 1 here. Okay, now let's apply the formula uv minus v u dash. Okay, u is x, v is e to the power x minus v is e to the power x, u dash is 1 dot dx. So the answer is going to be e to x e to the power x minus integration of e to the power x is e to the power x only plus c. This is the final answer of integrating this. The next question. Okay, here I know that when I'm going to integrate and differentiate the power of e, I should get a 2x, which is similar to the the function, but 2 is missing here. So if I had to add 2 on my own here, and to cancel the effect of this 2, I will write a 2 here in the denominator outside the function. That means the integration is going to be 1 upon 2 e to the power x square plus c. Now this is very simple. Whenever you see that the power, different derivative of the power is being multiplied with the product, you can use this method, and you can just write in this case you would just write e to the power x square. In this you can write e to the power x square, but since you have a 1 upon 2 outside, so you have to write that as well along with it. Moving on to the next question. Okay, now if you notice, the derivative of this is 2x plus cos x. Differentiation of sin x is cos x, which is already found in the numerator. So you can just simply write ln x square plus sin x plus c. Okay, so this is very simple. We are actually doing it by recognition. By looking at the question, we are seeing that whatever is in the denominator, if the derivative of that is found in the numerator, we can use ln. Otherwise we go with partial fractions. Okay, the next question. Yeah, okay, we know that the derivative of sin x is cos x. We can use substitution in this question, and as in while I was explaining you trigonometry and the integration of trigonometric function using substitution. Okay, whichever function, trigonometric function, has a power over it, you take that function without the power as u. Okay, so if I take u as sine of x, du upon dx is going to be cos of x. Okay, so dx, if you make the subject, it will be du upon cos of x. Now I'm writing cos of x u square. In place of dx, I'm writing du upon cos of x. This and this is going to cancel out. We're supposed to integrate this now. Integrating u square would be u cube upon 3. Okay, plus c. And u was actually sine x. So we can write 1 upon 3 sine cube x plus c as the final answer. So we've used substitution and we are done with this question. Okay, moving on to question number 1 from here. Let's do some of these questions. Use an appropriate method and integrate the following. You may find it helpful to discuss in class first which method to use. Okay, let's start with the first one. So if I just take, this is something very simple. It's just the question of the form cos of ax plus b or sine of ax plus b. How do you go about integrating them? Okay, we know the integration of cos is sine, so we'll write sine and the bracket as it is. After that, we're going to differentiate the bracket, and the derivative of the bracket is 3, so you divide it by 3 and plus c would be the final answer. Okay, the second one now. Okay, if you notice, it's cos x plus 1. Okay, if we notice that when I'm going to differentiate this, I'll get 2x plus 1 only, which is found in the numerator. But the only thing is that if this square is not there, then you would just write ln x square plus x minus 1, because the derivative of this is found in the numerator. But since there's a square here, we can use substitution, and we can take u equals to x square plus x minus 1. Du upon dx is going to be 2x plus 1. So dx, if you make the subject, it will be du upon 2x plus 1. Okay, we can write 2x plus 1 upon u square. In place of dx, I can write du upon 2x plus 1. This can cancel out with this. You're supposed to integrate this now, which is u to the power negative 2. Okay, now let's integrate. U to the power negative 2 is negative 2 plus 1 is negative 1 upon negative 1 plus c. So we can write this as 1 upon u plus c. U is actually x square plus x minus 1. Okay. Okay, so the final answer is going to be minus 1 upon x square plus x minus 1 plus c. Okay, moving on to the next question here, which is question number 3. E to the power 1 minus x. Okay, whatever is the power of e, you write it as it is as a first step. You write it as it is, and then you differentiate the power and divide it by it. So when you differentiate minus 1 minus x, you get a minus 1. So you divide it by minus 1 plus c. It's going to be minus 1 upon e to the power 1 minus x plus c. This is the final answer to this. Okay, next we move on to question number 4. Cos of 2x, very simple. Cos, the integration is sine x, sine of 2x divided by, differentiate the angle which is 2x, so differentiation of 2x is 2 divided by 2 plus c. The fifth question, ln 2x. Now questions with ln. So we have a special type of case here, although it seems to be just one function, ln 2x. But since we do not have any other method of integrating ln, we take it to be two functions. One function is 1 and the other function is ln 2x, and we go ahead with integration by parts to solve the question. So you can write this as 1 times ln 2x dot dx. Take this as the algebraic function, take this as the logarithmic function. Since algebra comes after logarithmic function, you will take this as u and you will take this as v dash. Okay, so if u is ln 2x, differentiation of u would be 2x, and differentiation of ln is whatever is with ln goes down in the denominator, and then you differentiate it and write it up in the numerator. Okay, v dash is 1, so whatever is v dash you have to integrate it, so v is going to be x. Okay, let's write down the formula. It's going to be uv minus integration of u dash. U is ln 2x, v is x, minus integration of v which is x and u dash which is 1 upon x dot dx. This is going to cancel out. Integration of 1 we know as x, so 2x ln 2x minus x plus c. This is the final answer to the integration of ln 2x. Then we move on to question number 6. X upon x square minus 1 to the power of cube. Now questions like this, the best idea is to solve with substitution. Okay, so I can take whichever has a power, like the denominator has a power of 3, so I'll take u equals to x square minus 1, and I know that that du upon dx is going to be 2x. If I make dx a subject, it will be du upon 2x. Okay, I can write this as x upon u cube. In place of dx, I'm writing du upon 2x. X and x will cancel out, leaving 1 upon 2 outside. I've taken 1 upon 2 as constant outside, upon 1 upon u cube dot du. U cube can be written as u to the power minus 3. Now, if I start with the integration, u negative 3, so negative 3 plus 1 is negative 2 upon negative 2. Okay, so if we integrated it, it's minus 1 upon 4 u to the power 2 plus c. Okay, we know u was x square minus 1, so we can write minus 1 upon 4 x square minus 1 square plus c. This is the final answer to the integration process. Okay, moving on to the next question. Question number 7. I can write this as integration of 2x minus 3 to the power of half. Okay, if I have to integrate this, I will add 1 to the power. I will write down the bracket as it is. I will add 1 to the power. Half plus 1 is 3 upon 2. I will divide it by 3 upon 2. Division by 3 upon 2 also means multiplication by 2 upon 3. And then I'm going to differentiate the bracket, and whatever is the result of the differentiation, I'm going to write in the denominator. So when you differentiate 2x minus 3, you get 2. So 2 you write in the denominator, simplify, and the answer is 1 upon 3, 2x minus 3 to the power of 3 upon 2 plus c. This is the answer of integrating root 2x minus 3. Next question is four x minus 1 upon x minus 1 the whole square into x plus 2. Okay, what we see here is that we have two functions. One is a linear function and one is a squared function here. So we can split it into partial fractions. Okay, so I can write it as 4x minus 1 upon x minus 1 squared into x plus 2 can be written as a upon the linear function plus b upon the other function which is squared, once without the square and once with the square. Okay, let's take out the LCM, and it's going to be a will be multiplied by x minus 1 the whole square, because okay, let me add a step here. If you take out the LCM is going to be x plus 2 and x minus 1 the whole square. Okay, so this is going to be a into x minus 1 the whole square. It will be b into x minus 1 into x plus 2 though x plus 2, and c will be multiplied by x plus 2. Since the two denominators on both the sides are the same, we can cancel them out. And let's start with solving for a, b and c. If I take a as 1, because I want to cancel out some of the brackets from here. If I take a as 1, this bracket will become, this whole thing will become 0. So I'm taking a as 1 and I'm substituting it in this whole expression. So 4 minus 1 is a 3. Sorry, I'm not taking a as 1, I'm taking x as 1. Okay, so 4 into 1 is minus 1 is a 3. This whole thing is going to become a 0. 1 minus 1, this is also going to become the 0, and as a result this whole thing will become 0, and this is going to be, if you take x as 1, it will become 3c. That means c is 1. 3c divided by 3 divided by 3. Okay, if I take x as negative 2, this whole thing will become 0, this will become 0, and you just have to plug it in here and this. Okay, let x equals to negative 2. So 4 into negative 2 minus 1 equals to a. Negative 2, negative 1 is negative 3 the whole square. Okay, this is going to give me minus 8 minus 1 is minus 9 equals to a into 9. A equals to negative 1. I have the value of a and c right now. I just have to find out the value of b. Now for value of b, I can take x as 0 maybe. Yes, let x equals to 0. This is going to be minus 1. A 0 minus 1 is a minus 1 squared plus b minus 0 minus 1 is a minus 1. 0 plus 2 is a 2. C 0 plus 2 is a 2. Okay, let's substitute the value of a and c into this to get the value of b. A was a negative 1 into 1 plus minus 2b plus the value of c is 1, so 1 into 2 is 2. Okay, 2b equals to 2 minus 1 plus 1. 2b is equals to 2, b equals to 1. Let's plug in the value of a, b and c into this, and then we're going to start with the integration process. A is negative 1 upon x plus 2. B is positive 1 upon x minus 1. And c is 1. So 1 upon x minus 1 the whole square. Let's integrate this whole thing. I'm separating them. Minus 1 upon x plus 2 dot dx plus 1 upon x minus 1 dot dx plus I can write this up in the numerator, x minus 1 to the power negative 2 dot dx. Why did I write this up in the numerator? The reason being, this I know I can do it with ln x, this I can do with ln x, but this if I expand that will become more complicated, so I brought it up in the numerator and I got this. Now I can integrate this. Okay, you have here if you notice, the differentiation of this is found up. The only thing is this minus, so if I take out minus as common, I can write this as ln x plus 2 plus I can write this as ln x minus 1 plus if I integrate this, it will become x minus 1 minus 2 plus 1 is a minus 1 upon minus 1, and when I differentiate the bracket, I get 1 plus c. So the final answer is ln x minus 1 minus ln x plus 2 minus 1 upon x minus 1 plus c. If you want, you can write both. You can solve this part separately. It will become ln x minus 1 upon x plus 2 minus 1 upon x minus 1 plus c as the final answer to this. This is the final answer, or you can even keep it like this if you want to. Okay, moving on to the next question, which is x cube ln x. Okay, these two are two totally different functions, so we can use integration by parts here. Okay, and this is algebraic function, this is the logarithmic function, and since logarithmic come first as compared to the algebraic functions in late, you will take this as u and this you will take as v dash. U is ln x, so u dash is going to be 1 upon x. V dash is x cubed, so v is going to be, if you integrate this, it will become v4 upon 4. Okay, let's use the formula uv minus v u dash. Okay, u is ln x, v is x square upon x4 upon 4. Okay, minus v is x4 upon 4 and u dash is 1 upon x dot dx. Okay, I can write it as 1 upon 4 x4 ln x minus, okay, 1 upon 4 I'm taking out as common, and x and x4 cancels out and you're left with x cube. Okay, so 1 upon 4 x4 ln x minus 1 upon 4. When you integrate x cube, you get x4 upon 4. Okay, plus c. So the final answer is 1 upon 4 x4 ln x minus 1 upon 16 x4 plus c. This is the final answer to this question. Okay, the next question is question number 10. If I take out 5 as common, we know that the differentiation of this is 4x minus 7, which is not here. So we can use partial fractions here. Okay, so if I factorize this, which is 2x squared minus 7x plus 3, I will get minus 6x minus x plus 3. Okay, so if I take out 2x as common, I'll be left with x minus 3 minus 1 as common, x plus 3. One bracket is 2x minus 1 and the other bracket is x minus 3. Okay, so I can write it as 5 upon 2x minus 1 into x minus 3 dot dx. Okay, so I can, in the next step, I can write this as 5 upon 2x minus 1 into x minus 3 equals to a upon 2x minus 1 and b upon x minus 3 dot dx. No, not dot dx. Right now we're just changing into partial fractions. Okay, 5 equals to a will be multiplied by x minus 3 and b will be multiplied by 2x minus 3. I can take the value of x as 3 and start. This is going to become 3 minus 3, which is a 0. So b into 2 into 3 is 6 minus 3 is 3. So I have 5 equals to 3b. So b equals to 5 upon 3. Okay, if I take x as 1 upon, okay, let me make 2x minus 3 equals to 0. So I will have to take x as 3 upon 2. Okay, let x equals to 3 upon 2. So it will become 5 equals to a 3 upon 2 minus 3 plus b into 2 into 3 upon 2 minus 3. This will become a 0. So 5 equals to a minus 3 upon 2. Cross multiplying, minus 3a equals to 10, a equals to 10 upon negative 3. So a equals to negative 10 upon 3. Putting it back into this, it's a is negative 10 upon 3 in the denominator. I can write down the denominator along with it. And b is 5 upon 3. In the bracket I can write x minus 3. And I have to integrate both of them. Okay. I can take out minus 10 upon 3 as a constant outside, leaving 2x minus 1 here. Dot dx, and I can take 5 upon 3 as common, leaving 1 upon x minus 3 dot dx as the inside. Okay, this will become minus 10 upon 3. Now in order to, I should have a 2 here so that I can write ln 2x minus 1. So 2 is missing, so I can multiply it by 2 and multiply this by 2 as well. So I can write minus, I can write this as minus 10 upon 6 ln 2x minus 1 plus I need, okay fine, this is perfect, ln x minus 3 plus c. Okay, so I can write 5 upon 3 ln x minus 3 minus 10 upon 6 ln 2x minus 1 plus c. Okay, 10 upon 6 we can simplify, it becomes 5 upon 3. If I take out 5 upon 3 as common, I'll be left with ln x minus 3 minus ln 2x minus 1 plus c. Okay, 5 upon 3 as it is. Inside I can apply quotient law, x minus 3 upon 2x minus 1 plus c. Okay, 5 upon 3 can become the power x minus 3 upon 2x minus 1 to the power of 5 upon 3 plus c. This is the final answer. Either you, if you want, you can leave the answer like this, or you can solve it further and write this as the final answer. Moving on to the next question. Okay, let's take this one. Okay, when we see that the differentiation of the power of e, which is 2x plus 2, is found here, but the only thing is that 2 is missing out of this. So what you can do is, since we wanted 2 here, you can add a 2 on your own. As a result, you, since you added this 2 on your own, you have to multiply it by 1 upon 2, so that you can see that the effect of this has cancelled out. So you can write 1 upon 2 e to the power x square plus 2x plus c as the final answer. Okay. Now this question. The result of the differentiation of sin x plus cos x is cos x minus sin x. Okay. But it is opposite sign. So I can multiply it by negative here. Sin x minus cos x upon sin x plus cos x dot dx. I have multiplied it by negative so that both the signs become the same. Both the sign becomes what we want. Okay, as a result, you multiply it by minus 1 outside. So minus ln sin x plus cos x plus c will become the final answer. Okay, this question. X square sine of 2x. Since I know that if I'm going to differentiate this, it will become cos of 2x and doesn't have any connection here, I can use integration by parts here. Okay, so this is the algebraic function, this is a trigonometric function. In late algebra come first and t comes afterwards, so I can take this as u and this as v dash. Okay, so u is x square, so u dash is going to be 2x. V dash is sine of 2x, so v is going to be integrating this. Integration of sine is negative cos 2x divided by 2. Okay, let's apply the formula. It's uv minus integration of vu dash. U is x square, v is minus cos 2x upon 2 minus integration of v. Now this is a negative, so negative negative becomes positive, so I'm making it positive, and 2 also I'm taking out as common. I'll be left with cos of 2x here into u dash. U dash is 2x. This 2 and 2 can also cancel out, so you're left with minus 1 upon 2x square cos x plus integration of x cos 2x dot dx. Okay, now we can because here also we can use integration by parts, so I'm writing minus 1 upon 2x square cos x as it is, plus this is algebra, this is trigonometry. Algebra has to be done before trigonometry, so that means this is u, this is v dash. Okay, so u is x, so u dash is going to be 1. V dash is cos of 2x, so v is going to be, when I integrate I get sine of 2x divided by 2. Okay, so it's going to be the same formula, uv or vu I can say, half of sine 2x into u, which is x, minus integration of v minus half sine of 2x minus v into u dash, which is 1 dot dx. Okay, minus half x square cos of x plus, okay, it's half x sine 2x minus 1 upon 2. If I integrate sine 2x I get positive cos, negative cos x, so it will become positive cos 2x divided by 2 minus half x square cos x plus half x sine 2x plus 1 upon 4 cos 2x plus c. This is the final answer to this question. Okay, thanks a lot for watching the video.